Welcome. Hello, hello. Heck yeah. There's no power, source power in this. It's all running off the cat bank right now. I do have a 9-volt support pack, but it's off. It's off. It's got a little switch on it and it's off. I'm just blown away. This thing is actually moving without source power. Well, you can consider the cat banks the source power, but the source is the pickup coils. Normally this wouldn't be able to work. I mean, but it's working. So cool, man. It's so cool. See how slow it's going? Momentum loss, like, if it's going this slow, it's eventually going to like stop relatively soon from here. But it will stop. It will definitely stop. Now I'm measuring both the stator and the rotor. So if the rotor stops and the stator continues to spin, that's gold. That counts. Now I'll show you what it looks like with power on real quick. So you get a little bit more response from the rotor, and that'll build up. It's only a 9-volt, and it's being split between 2 reed switches. But you can see with power, it's totally different. I might put a new battery in there just to, but it's definitely working. It's not a rechargeable 9-volt, it's just an alkaline. So when it dies, it's done. So this is with power now. Turn it off. Let it settle in. Wow, that is so awesome, man. And somebody alluded to the fact that I think it was Make. Make was the guy who, I think, yeah, alluded me to the fact that this could run itself. Not start itself, but run itself. And see now the stator is continuing to spin. I stopped the rotor, but the stator in step, man. And if I like, we need to get a little bit of weight. So we can get the coils down a little bit farther. More of the magnet will be across the coil. Right now it's about halfway. And that's because of the maglev. You don't have control over how high that maglev is going to, or that this maglev is going to lift. So that's your only like unknown variable really, is that how high is the magnet on the magnet gonna elevate it. And then right here is a little bit too high. So I might put this coupler in there and let it rest on that. A little lower. But it won't be maglev, so it might not even go. But see, if it wasn't working, it would be syncing up with the rotor. But there are no batteries in there, so the magnetic attraction that the other rotor had is not with this one. There's no magnetic coupling going on with the batteries and the magnets. And see, it's still spinning. And it's not just because it's all greased up or anything. It's literally spinning at the same speed. See that? It stops slowing down. That's my point. Now it'll stop eventually, but I mean, it gets into this zone where it generates enough to, what it generates is enough for it to push to the next magnet and generate the same amount. Now when I say generate, when the magnet passes the pickup coil, it generates some AC electricity, which goes into this cap bank. Okay, and then it comes out the other end DC, which is connected to a reed switch and one of the drive coils. So there's two drive coils hooked up. I might try it with one drive because that is the name, one drive. So not that one, but this one will unconnect the negative. And see now with one cap bank connected, I don't know, the energy seems to be going through both cap banks still. It's not like taking the path, it's taking both paths still, which is awesome. I'll show you. Hello, hello. So you see those lights flashing on the cap banks? See, the power is off. Is it off? Yeah, it's off. No, it was on. Yeah, we were testing the cap banks. And you see the one that I unhooked has still got energy in it. And I'm just trying to demonstrate how the power goes through the pickup system and out the other end. The one that's hooked up to the reed switch currently doesn't have any light on it. Now see, the rotor is stopped, and that's okay because I'm just in motion, and you can tell that the stator is definitely being affected by something. Yes, it's an AC/DC machine for sure. You can see it, man. It's still moving. That's awesome. You can hear the reed switches clicking. Yes, sir. AC to DC to drive. Hello, hello. See, the only power that this has got connected to it right now is the 9 volt in the middle there, and it's off. So that's awesome. Now, I find the difference between the power from a battery and the power from the cat banks is that from like how the power is derived. So the power from the pickup coils, this is what you get from that. Nice, steady, slow, but continuous. Now, I'll show you the difference again real quick. We'll turn it on. Flip the little battery switch on. Oh, let me do this. I'm gonna hook the. Well, I gotta put this back on the tripod. All right. Oh yeah, we're gonna connect this back. So we're using all the energy instead of splitting it in half and only using half of it. So let me put the negative back in. See, the energy went away immediately. Once you hook the end of this the DC end of this cat bank up, all the energy in it will immediately flood out. Yes, sir. No, it's just maglev, but all the motion that's happening right now is off of its own power. Let me try and see. That's off. Let's turn it on. So now both cap banks are hooked up to the reed switches, and the lights on both cap banks are flashing, which is awesome. So this is with power. See, it's different than what we were just looking at. I know it looks the same, but it's way different. Because there's amperage in the battery. We're not getting barely any amps, maybe 20 milliamps off of the coils. All right, so let's try a test. We're going to go real slow. See that? Yeah, but the energy that fills the caps is itself. There's nothing in the cap banks until I until this thing puts it in there itself. Okay. Yeah, maglev. Yep. There's definitely a maglev in here. There's one on the bottom there. So the rotor is floating and the stator is floating, which makes it very easy to spin. All right, let me whip it real quick. Now I'll counter rotate it. You can hear the reed switch is working, and you know that there's energy going into the reed switch because we just saw the cap banks light up. Will it stop? Absolutely. But how long will it go for? That's my question. Can it run itself? Is this it running itself? Or is this all momentum? It's up to you. You decide. I know what it is, but you're more than welcome to give your opinion. See, now with those 6 magnets going that fast, there's definitely a lot of juice flying into those cap banks. Is it diminishing? Yes. But what I want my experiment to include is to get it to max speed, and then with the remote control, be able to turn off the power and see what happens then. Because at full speed, nah, man, this thing will go for 3 days by itself. There's no power inside of it. There's just this 9-volt battery on the top, and it's off right now. See that toggle switch? It's on the off position. Now the rotor usually stops first, and I think it's because of this extra bearing that I got in, because this plate wouldn't center, but the hole in the middle of the plate was the exact size of the bearing. So I stuffed the bearing in there just to make it, balance. I've been saying that for the whole time I've been on here, dude. Don't do that. Quit and stop. Now I said the rotor would stop, but the stator, we're measuring that too because it can spin. And the stator can spin without the rotor spinning. With power, absolutely. No. No, it's not about this times 100. It's about how fast it's going. Hello, hello. Because AC is generated from coils by how fast the magnets are passing them. It has to do with speed. Awesome. Thank you. Friction on the bottom, where? In here? There's no friction in here, dude. The friction's on the top at the bearing where I said it was. But I'm going to push this down a little bit. It's even like you can hear it. You see it speed up though? Because I got the magnets more in range of each other. The electro mags and the permanent mags are now more aligned. See, if I let that go, it goes up to about halfway. Like they're only half. And that's because the maglev underneath the rotor has lifted it higher than the magnets. Yeah, the bearing on the top. You can hear it grinding. Hear that? I need to get about this much weight on it. So it's just above the magnet down there. You can hear it. All that friction and the thing didn't stop. What does that tell you? What's up, Mike? What's going on, brother? This thing is actually working. I'm so shocked. So I took the AC, converted it to DC, and then I ran it through a reed switch, and it works awesomely. Yeah. All right, I'm going to let it run for a minute. So I got a 9-volt battery that I have connected to both cap banks, and so it divides the energy equally as it uses it. Or it, you know, what I'm saying, it'll run out faster. But that's a perfect speed too, man. That's awesome. I can just look at it. That's cool. No. I gotta get up. See, you gotta be really heavy in the pickup with this. You only need one drive coil. Okay? One really tiny drive coil. And the rest of it has to be pickup. Oh yeah, man. This is my show, dude. And if I want to spin it, I will spin it. I don't have to prove anything to you. There, I'll stop it completely. Rotor, done, stopped. It's so cool, man. I never thought it would work. You know, I was always one of those people that say you can't do that because it'll lend itself to death. That's exactly what I always tell myself. There's lens, it's not going to work. And I mean, like the rotor will stop every time, but I'm pretty sure it's because of this bearing on the top here. Because it's forcing that black plate to the center. It's forcing it because it's not lined up right. And I love that I put the battery on there because I like counter rotation, and counter rotation happens with amps. Okay, you need a push or a pull, but mainly a push, and you need amps to push with a coil. If you don't have amps, there's no oomph. I don't care how many volts you put in, there's no oomph. I believe that. I believe that conceptually, this is awesome. I think conceptually, this is the future. But, I don't think this particular thing is going to be even around very much longer. If anything, it's going to be in a trophy room. Be like, yay, one more thing I made that works. Yeah, basically there's the magnets on the rotor on the stator. So the permanent magnets charge the cap banks when they pass the coil. So it charges the cap banks, and the cap banks run the motor. But there's an equilibrium that I haven't like found yet. But I know that all you need is one drive coil, one 20 gauge drive coil. That's all you need. And make it a 20 gauge and a 28 bifilar, and then link it in series. That's all you need. 200 turns. That's it for drive. Everything else on this thing should be for pickup and distribution. So all the other coils generate AC electricity, go into the cap bank and then out the cap bank into the reed switch to drive the one coil. You need a lot of power. You need a lot, but you want to keep your coils small. Okay, you don't want big coils or you're not going anywhere. It'll lens to death. It will. You want See how big the coil bobbin is? That's about the size you want, or smaller. You don't want anything big. This is made out of plastic. So whoever thought this was going to Mars, forget it. All right, Mike. I'll talk to you later, man. Hell yeah, Playboy Bunny. All right. Yeah. A bigger, much larger with a cockpit, maybe. Absolutely. That could go to Mars. This isn't going to Mars. Thank you, Hyon. Thank you, Mike Does. See, look at that stator go, man. You can't tell me that that is moving on momentum because it's constant. You can't tell me it's moving on momentum. This is the zone that I was talking about, where it gets to the point where it's almost equilibrium and it maintains the speed. I know, isn't that something? I think it has to do with these cap banks that I'm using to convert the energy. There's 4 bridge rectifiers on it. on each one. And then there's 4 AC caps on each one and 20 DC caps on each one. That's moving on its own. Well, I spun it, but it's running itself. But this can't sustain itself. Even though it's in the zone, it will eventually fall out of the zone. It's just the way it is. There is a lens effect, but it's a small lens effect because the coils are not humongous. That is so cool, man. I never thought it could happen. You know, I didn't think that it could make itself move, but that is sustained motion on the stator. And the power is off. Just making sure that it's off. Yeah, it's off. But you can't see it, but the words are written on there. On, off. I can barely see them. So with that large amount of momentum in the beginning, it was allowed to slow down to this spot and just sink in. All right, let's turn this on again. See, I turn it on instantly, it starts counter rotating because there's amperage now. Yeah, I haven't been able to really make anything counter rotate without power, like a battery or power supply or, you know, a charged cat bank. But it's awesome, man. I figured this one out, that's for sure. So that's the counter rotation. Now, if I turn it off, the rotor will stop. But you would think that stator would stop kind of relatively close or soon after that, right? Now there are there's maglev, it's floating there, so I don't even know really. But I do know that every time you hear the reed switch click, watch how it jolts. See that? That's real. Let's see if this thing will pick up speed just for me touching it like that. You can't run a counter rotator self-running thing on a load, dude. I would never put a load on this. That's stupid. That would definitely like make it so it wouldn't work. Why would I do that? I'm gonna have to reprint this because it is wobbly. And I think if I can get it straight, that little like hiccup won't happen because it literally has to go up a hill when it turns around and it goes like this. Yep. So I have to give it enough momentum to get over that hump. Maybe that was it. We'll see. See, look at that. Look, it starts speeding up, but then it's got that hump because it's not flat. I don't know, man. Blame the printer company. All right, so we'll give it a little boost, see if we can't get some. Can it run itself? This is a counter-rotating DC pulse motor. You can see it definitely picked up speed. We got over the hump and look at it go. It's like slow, but it's definitely moving faster than when I started it. All right, we'll turn it on. See, this has its self-run capabilities, and then I put a 9-volt battery on it just to get the counter rotation, because it won't counter rotate on its own because there's no amps. And you have to have a push for it to counter rotate. Equal and opposite force, you know. So if there's no amps, there's no force. Now there's amps on this right now because I turned it on. I turned the 9-volt battery on and it's split between 2 reed switches right now. Hello, hello. Yes, it is. It is a magnetic motor. It's a DC brushless counter-rotating pulse motor. All right, so turn the power off. We'll stop the rotor completely. Now the power is still running through the rotor and through the reed switch, so that stator will continue to spin probably until I stop it. And the battery is off. Yes. Maybe. I don't think any would. I'm not trying to do, stuff that could get me in trouble, but maybe. I mean, this right here doesn't, you can't really connect anything to it. It'd have to be, a static pickup and a wireless thing, maybe infrared, because you can't hook anything up to that. Stator won't let you. And this is supposed to move too, so that again, that right there won't let you. I mean, you could probably hook a commutator plate up to the bottom of this thing and get a really shitty reading, but that's pointless. But yeah, man, if there's an application for proximity, it would have to be a proximity generator, like something that would be next to it. And then this gets going really, 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 really fast. And 2 things would happen. You get energy from proximity, and this would start to rip a hole in time and space. Is it destructive? I don't think so. I don't think it's destructive at all. I think stuff like this happens all the time. because counter rotation is 100% natural. You don't have, there's no way you don't control it. It is not controllable. You just build a standard pulse motor the way it works, and this will happen every time if the stator can move. As long as you have power going through it. Here? You mean out here, right? Super, yes, okay. I am working on that. I am working on a tri-level counter rotator pulse motor. I was thinking though about putting a magnet in the middle first on the shaft. I'll show you which one I'm planning on doing that with. Boom, one of those. I got two of them. And so I'll make a little cocoon for it on the PLA, and then I'll shove a pole in one side and a pole in the other, and that will become my new shaft. And then of course we can go even a fourth level and have the coils on the outside. But as you can see, the distance here is quite immense for typical generation. I mean, that's an inch and a half or more. So I mean, I'd have to make a different one of these. But yes, man, that is totally in the works. Thank you, Super. And I know exactly where we're going with this. Yeah, the time deviations in I've actually experienced some of that, like slow lightheadedness. It's fun. It's great. I don't see a problem with it, actually. See, this particular device has taught me one very important thing. That's how to let go. Now, the one thing that I can do is I can replace. I can put, infrared toggle switch on this, and we can get it going really fast, maybe. And then hit the button, turn it, cut the power when it's going really, really fast, and see how long it'll go for. See, because it's spinning, you can't turn it off unless you stop it, which is totally counterproductive. So this is actually like my 8th iteration of this counter rotating pulse motor. I've done like 8 or 9 different ones. And the cap banks haven't been particularly useful until now when I combine them with the reed switch. I always tried to run a transistor off of that, and it didn't work very well. There's my 6th iteration. That does run on a transistor. It's very powerful. Oh, that's so relaxing. Wow, that is so awesome how, like, it's mesmerizing how rhythmic it is. Here, let me try and get one of these. What's up, Gerald? Oh yeah, I turned the battery on to get it to counter rotate. But I'll reset it real quick. Yeah. Okay. Now I just want to nudge this in a direction. Let's see if we can get some speed on it. Just a little bit. Is it going fast enough to go faster? Is there enough pickup there and enough magnets there to generate enough electricity so when it hits the reed switch, it'll boost, you know? I mean, you can see it jolt just off of the magnetic uh, AC pickup from the coils, man. You can just, it's awesome. Ah, I'm so happy. Really, dude? Alternator generator? That's awesome, man. That's, if I put coils on this and magnets on this, I might have something like that as well. Oh no, this is very down to earth. It's the counter rotating DC brushless pulse motor. Turning on the power. See, now it's rotating with it. And now it's counter rotating. Oh, it happens every time, man. It is a law of nature. All you got to do is untether your stator, and it'll do this. It'll go the opposite direction your rotor's going in. But of course, you got to have an electromagnetic rotor. I mean, you can't do it with, a rotor with neos in it. You can't do that. That won't work. Unless you have a stator that can rotate with your coils on it. And as long as you got batteries on that stator, that's fine. You need batteries, you need the circuitry, and you need the coils. All of it has to be on the rotor. The only thing that the rotor doesn't need to have is neos. So that basically picked up from a dead stop on 9 volts split in half. So 4.5 on each reed switch. Or it's 9 on each reed switch and it'll last half as long. That's probably what's really going on. But 9 volts is way better than 12. I'm gonna check out I'm gonna check out that alternator, man. Gerald, that looks cool. Oh yeah, man. The one that I was running with the batteries and the 12-volt battery packs in it, they were in such proximity that they were actually charging each other inside the unit. Because I put them in there, they were 12.5 a piece. I took them out. One was 13.5 and the other one was 13. I was like, what the hell just happened? I'm like, don't I have to hook this up to something to charge it? No, it charged itself, literally. It won't run itself because you need the batteries to make it work. But the batteries did something really weird. All right, cool, man. I'll check them out. Hell yeah. Actually, I might let this run like all night because it looks safe to me. So, and see how long that 9-volt battery will go for. It's already half dead, so we'll see what happens. Hello, hello. Aaron, what's up? Yeah, man, it is. It's trippy, especially because it's balanced, man. It's like, whoa. But I do have to say this. I'm gonna switch the rotors in just a second. The 12 volts. This is 9 volts through 2 cap banks. I'm gonna show you what the other one does if you haven't seen it already. Balls. Woo! No, there's no resistors. There's 4 AC caps on each one, 4 bridge rectifiers on each one, and 20 DC caps on each one, and that's it. No resistors. There's not a single lick of resistance on this. Now, the ones that I did have hooked up, which might be the ones you were talking about, got in the way. Thanks, David. So that's 9 volts. All right, I'm going to get the other rotor real quick. I'm going to put you back up on the pedestal here. All right. This thing is awesome, man. It's featherweight. That's probably why it's riding so high. And this one goes really fast, so I had to take everything down. Hear that chirp? This is the one you really need the infrared for because it goes really, really fast. It can get going like, I don't even know how fast it can go. I stop it right about where it is. Where I stopped this time, man. This thing is mean. It needs an infrared toggle switch. That's fun though. That chirp, that speed. Oh my God. And the counter rotation, beautiful. All right, I am back. Let me read up on this real quick. This is OneDrive. In all of its various components, it's called OneDrive. With a 1, not ONE, numero uno drive. Nah, nah. See, I knew you were going there, Gerald. I just explained that it's not O and E. It's one. And yeah, there's a big difference between spelling a word and writing a number. Hell yeah. One start. Or how about no me start one drive. All right, if you can hear the reed switch, it's right about here. You can see it being pushed. But yeah, I mean, little power begets little push. All right, you want how you want me to do it? You want me to do it on 33 hertz or 45 hertz? I just love the reed switch clicking, but there's no arc. That's the thing, man. That's how you can tell there's no amps going through it right because there's no arc in the reed switch. Thank you, sir. Yeah, yeah. Now I'm not sure exactly what's going on right now, but I think maybe somebody's trying to put together a PCB board for this, so that or for the other one, so I can get the transistors and everything as flat as possible and more balanced. Because that other one that I had up on the pole here shook everything, if you couldn't tell. Because it's like there's one cap bank on it. So let me explain it. There's two pickup coils and there's two drive coils. One drive coil is hooked up to a battery, and the other drive coil is hooked up to the cap bank, which is hooked up to the two pickup coils and will only run when it's on. But when it's on, the 12 volts has a tremendous effect. And wow, what was I getting at? 12 volts. Yeah, it's just, I forget my point. There's so many points, though. All I know is that the 12 volts makes it go a tremendous amount faster. Like, unbelievable. Now, I think the reed switch, oh, that might be what it is. See how it's slowing down now? I turned it on. It's because the reed switch wants everything to go in the opposite direction. There's no starter coil. Now there's a 9-volt battery that is running it right now. The pickup coils are 2,222 turns of 30 gauge in 4 separate coils, Lincoln series. And now that generates enough for this thing to very slowly run itself. Now what I would do, instead of making bigger coils, is I would arrange for in between them to have another spot for another coil. That's what I would do. Because as soon as you get it a certain size, man, it's not going to run. It's just not going to run like this. With 9 volts, it's only going to spin like this. Because it's split. Let me show you how it's split. All right, so the pickup coils are hooked up right here, and then they're split into the 2 cap banks equally. And then the 9-volt battery is hooked up into this cap bank, and through contact, it gets into both cap banks equally. That's a blessing to me, man, because I don't have to like do anything weird with it. I just plug it into this one, and it affects this one the same as it affects this one. That's awesome. That's all there is to it. There's nothing in here. There's nothing underneath this. And it is glued down. But yeah, you know what? I am craving some speed, some quickness. So I'm going to put this back up in the thing. Thank you, Gerald. You are the man. All right, so I'm going to swap out the rotors and we'll get something going real quick. And you know, I can always change the 9-volt battery for a 12-volt battery. All right, so let me see if I can get this transistor to start and run at all. See, there's batteries in here. You can see the magnetic coupling going on there. Okay, so there is a magnetic hold on this one. But so you turn it on. Oh, wait a minute. We're going to see if this one will run. It's not going to kind of rotate without power. I'll turn the power on in a second. I do believe that it's actually self-running right now. It's not going to kind of rotate, like I said, without power, but with the pickup system, there's only 2 coils on this one. Yeah, man, I don't want. I've had a few, like, you know, hairy moments on lives recently where components of these have been flying off. I don't want that to happen. But I do love the speed. Automatic counter rotation. All right, now I do have another thing to show. It doesn't have to counter rotate. Let me break this down real quick. And now I'm going to have to switch the magnets. But this is a solid stator, virtually the same thing, more the shape of a saucer than the other one though, for those who like the UFO thing. And then we move, look at these neos, man, they're freaking huge, huge. And we put this maglev in the middle here. Now it's nice and magnetized to the one on the table. That's not going to work. All right. I like having them in there nice and tight sometimes. Right. These like south for some reason. So now we got a lot more shaft to work with. So we got a lower center of gravity. Now this is still unbalanced, so it's still going to rock. I don't like how it's hugging the shaft like that. I don't like that. I don't know, maybe if I rub some WD-40 up and down the shaft. That's what I'm thinking. Leave the bearings out of it. Just put it on the shaft. See it jump into that like 5th gear? Wow, dude. Man, it gets to this point where when I put my finger on there to stop it, it doesn't slow down at all. So, I mean, the amount of torque on this thing is, you know, I don't know. It's a lot. No, it can't throw a sledgehammer. No, it can't break a 2x4. But I still think it's a lot. See how high it's too light, man. I think I'm gonna remove the plate and fill that thing up with like concrete or something. So this isn't going to last very long. But and I think it's mainly because of the bearings. But it's obviously working. I mean, for me, it's obvious because I spun it without power, without anything on it. I spun it. And this is different. Okay? This is totally different than that. It's not the weight, it's the way it moves around the shaft. It's but yeah, I would say there's definitely not enough pickup action going here for it to sustain for any long period of time. But the concept is sound. And I keep on saying, if we can get this up to speed like the other one, and then cut the power, this is going to run. It's going to run itself for, I want to say, 2 or 3 hours. See, this stator looks like it's moving this way, but that it's not moving. And that's how I know that the time thing is real. The time thing is so real that what I'm describing, it looks like it's spinning right now to me. This part. I'm just gonna let it keep going, man. See, I think it's in the zone now because it's going real slow and it's not slowing down like as rapidly as it was before. So I'm gonna remove 3 magnets and I'm gonna put the other rotor on here. This is awesome, man. I built this today and I'm like, I'm always using transistors and it hasn't been working the last couple of times. So I'm like, we're gonna use a reed switch because a reed switch will take any kind of energy, man. My homemade switches will do the same thing. It'll take AC, DC, and it'll make an arc. You know? No, no, we're leaving that one in. Okay. So we're gonna shift it to these. Because I saw something the other day which made me pause. The 6 magnets, then I took 3 of them out like I did here. And there was more energy being, the cap bank lights were brighter with 3 than they were with 6. It might have been because of how I spun it, but it definitely, I thought it more had to do with the spacing of the magnets. But you see, between each one of these, it has to push farther now. And it will, it does. The bearings are so good that it doesn't really matter. Let me get this off of here. Yes, close up. Sorry if you're gone. got really into what I was doing. All right, so I'll turn the power on. See, now with power, 6 magnets is better. Let me spin it now. See if we can't get some rotation on 3 magnets. I'm going to get the other rotor. That's what I'm going to do. And I'm just going to show you how much easier it is to manage. Still got to put your finger on it, but yeah, that's cool. All right. All right, let me get the fast one on here, and then I'll get it close. Yeah, the lower center of gravity on the shaft prevents it from wobbling as much. That's for sure. Oh. All right. And for being such a good audience, I'm going to show you my first one that I ever made. I have it right here. Well, more like half of it. So when you were all like talking about UFOs, man, I'm with you. See? That was my first one. And this will spin one way, and the rotor will spin the other way. That's beautiful. Just have to print out a few more of the top part, you know. Isn't that weird? How I spun it in this one and it didn't go very far, but when I spun it in the Utron counter rotator, it spun a lot more, a lot farther. So much more easy to manage, you know? But you can see everything shaking. Now let me explain this rotor real quick. Or maybe I already did, but you know, the battery is hooked up to one drive coil, and the 2 pickup coils is hooked up to the other drive coil through a cat bank. So basically what this thing does is it'll spin fast with the battery, but the faster it goes, the faster it'll go. Because the transistor functions based on how much voltage and amperage you shove through it. The more voltage, the more speed. But it looks like we've reached a climax. That's awesome. All right, I'm taking it off and I'm bringing it over. we'll get the up and down look on it. Well, there's that. I'll get the counter rotator up here and we'll get another view. For this rotor, it's 2 to 1. It's weird though. It's 2 pickup coils to the 1 drive, and then the other drive is battery operated. It's 2 to 2 then. But let me think here. Coil wise and neo wise. So if we go coils, neos, it's 1 to 3 times 2. That's so neat. I never been able to like just let it roll, you know. But here, let's get some action happening here. All right, I'm going to swap it for the counter rotator, and we'll get some more above the rotor action in just a second. That's cool, man. I can feel when I lift the maglev up, I can feel all that magnetic energy in there, man. It's powerful. Boing. So force a counter rotation. All right. I think it's that magnetism in there. I don't think this one will ever spin itself. There's too much coupling going on. So this is 1 drive. All these rotors that I'm putting on here have 1 drive coil that's hooked to a battery. So like 1 drive coil. So it's called 1 drive. All the other stuff is either through cap banks, and it's not a drive. It's a boost. It's a booster. So I did virtually the same thing with this one that I did with the other one, except I used a transistor instead of a reed switch. But I like that, man. That is so smooth. Let me get it off the wheel here and go over there and show you. That is so cool. Wow. Man. Nah, there's only one drive coil. Oh, you're so welcome, guys. I appreciate it. I appreciate all the questions too. Pardon me if I sound like a dick. I have been fasting and awake for 2 days, so that's what I'm doing right now. I don't mean to be in anybody's face. See, anything more is too much. I've already tried it. I've tried 2, I've tried 3. Anything more than 1 is too much, especially for this size. Even with, I think, our you know, IR switch. Wow, that is so neat. I never actually had it run on its own before. Must mean the battery's getting low. But that's awesome. It's very relaxing not having to. I can actually hold the phone and get you guys in here a little bit, see what's going on. So that is a half of an Utron. It's a cone that the height is half the width of half the height of the base. So half of the base is the length of the width. Yeah, I saw Saturn had like a hexagonal storm in its hood. Oh, the rings around Saturn. Very cool. Yeah. Wow, it's so smooth, man. I've never had it. Wow, I'm so happy. Gander. Yes, single angle vectoring. So virtually this thing will push 6 times per rotation when all the magnets are in there. So I mean, like the torque when there's 6 magnets in there, I wouldn't be able to stop it if it got going fast. I'd have to kick it off the table. But 1 is like manageable. But yes, if you wanted to go super duper fast and you're looking to ride one of these things to Mars, you're going to want more than this. But still, even if it's like a huge rocket-shaped thing that's 25 miles long, you're going to want 24 miles of pickup, and you're going to want 1 drive coil. Maybe 4 drive coils. But still, man, the ratio between pickup and drive should probably be 3 to 1. Or 4 to 1 even. And then you got to make sure that your drive coil and your pickup coil are the same mass. They got to be the same mass, and they got to be in proximity, or it just won't work. Because that proximity boost that you get from having the drive coil and the pickup coil be next to each other is immense. You can't live without it. But see, like this one doesn't have any of that. There's only one coil on each 90 degrees. So there's 2 pickup coils and there's 2 drive coils at 90 degrees. So this one is much more manageable. I like the other one. I like it running itself, dude. That is like and you know, to hell with anybody who says it can't happen, because I will show it to you happening right now. Let me turn this off. Yeah, I've heard a lot of people say that due to lens, you cannot, the pulse motor will not run itself. For any time at all, it won't. It'll stop. That's what the consensus is right now, that it's just going to stop. Because the coils are going to make it stop. Now I really do need to get weight on the inside of that, so it'll get more magnetism on the coils. All right, let me try that again. Yeah, I think because it's a reed switch, there's definitely a direction that this thing will go better than the other way. I'm not quite sure which one it is, though. Probably the way I had put it before. See, now, with the self-running, it's the stator that wants to move. I think it might be because weight, I don't know. But let me put the other magnets in here so we can get a better reading on this. You can see that. Oh my God, that is such a big push. But you see how it's wobbly? When it dips down, the magnets actually go below where the reed switch can read them. It's like, what in the hell? Mm. All right, let me get my my tool. Your big old tool almost broke my toe. I got an idea. I don't know if this is gonna work necessarily. But I'm gonna use this instead of the maglev. Wow, that's so powerful. Unbelievable. Unbelievable. You wouldn't believe me if I told you. That's too low. I'll lift that up. Well, we'll find the perfect height for that, and then I might tighten it up. That's still too. Oh, wow. Okay, that might not work. That's way up in there. Yeah. Where did I put that? Let's try this bearing. See if we can. No. All right, we got it. Now, if we had another 26 millimeter bearing, but we don't. Huh. I wonder if there's a way to let me show you. Is there any way to redact that from up in there? Like pull it back out without having to undo everything? Got it. Wow, that was awesome. Let me just put this back on here. All right, so let's try that again. Now let me clamp it in. See, these little screwdriver sets are really handy because they'll even do hex nuts. if you don't have one of your Allen wrenches. I just want to see what the reaction will be. Having more of the magnetism hit the coils. Yeah, it's a little more. Maybe it could go down a little farther, but I don't know. Probably. So we'll get a that battery might be dead. No, I like the maglev better. How about you guys? But look at that stator go, man. That is definitely powered. Yeah, I think it is. Actually. Okay, we got a little boost. Power's off. I think it's above its like range. We're gonna call it a range. So it's gonna from here to here and everything in between here is gonna be about the same speed the whole time. But because there's no maglev in there, this thing isn't gonna spin much. But see, with the more coil magnet saturation, there's definitely more energy coming out of this thing right now than there was before when I took the maglev out. So I need to find, yeah, all I need to do is get some weight in there that's evenly distributed and it'll be fine. It'll work so well. Because right now all it is a hollow box. Let me get a look here, see what's going on. That's right. When it gets to 88 miles per hour, you're gonna see some serious shit. It's dark in my room. Yeah, let me use my infrared remote with the range. Give it a little nudge because there's a hump. I'll show it to you. See how it's wobbly? Like it goes down like this, and then it goes back around like this, like an orbit. Not perfectly straight. Don't act like I'm the only person to have done this. So, I mean, yeah, it could totally make a hole in space-time, but am I the only one that's done that? And is it really so dramatic? You know what I mean? If everybody's doing it, why is it such a bad thing? And then we'll find out that it's not as continuous as we think it is. There's so much we don't know. There's so much, you know. To think that what we know now is gospel is wrong. Just wrong. I'm gonna get the maglev back in there. I like counter rotation. But hell no, man. I don't necessarily believe in all that. I've heard it said like more than once, but it doesn't mean that that's what I believe. What do I believe? This is a DC counter rotating pulse motor. That's what I believe. But that stator, that's moving on its own because the power is on. Oh no, it's off. Yeah, power's off. Look at that. That might go. I don't know how long that's gonna run for. I'm gonna let it roll though. Because honestly, I haven't heard a deviation yet. I know it will stop though. It always does. Maybe I should try and put all my eggs in one basket for once and see if I can't get this thing to run for a day or two. I'm wondering like if there's a weaker magnet I could use. But I don't have. Oh. That's so cool. I mean, the power is literally off right now. I don't know. I don't know anything. I haven't read up on it, so I don't know. We're talking like time travel and stuff like that. I don't know, man. Just what a total sham it all would be if that was possible. All of it would be just fake and made up. By the people who can time travel. It would all be bullshit. All of it. And you know what? All those bad people that never got caught, all the same guy. All the same guy from Jack the Ripper, to whoever else didn't get caught. All the same guy. And for good people, like Amelia Earhart. She was awesome. I'm not giving anybody, not that you don't blow it out of context, because that would be stupid. It'd be dumb, man. I'm not trying to advocate for anybody, really. I'm just saying that, if time travel was possible, then it's all bullshit. All of it, man. Like the Philadelphia experiment, I think it was something like that. They I guess went back in time and stuff, but they didn't mess with anything. So did they really even go back? It's like there's no way to tell, and that's the way they wanted it. You know. Of course, there was like photographs and stuff, but that's real sketchy evidence, man. That's sketchy evidence. But it's evidence, There was a blurry freaking photograph from 1865. Sketchy, dude. But, okay, I guess I can take a leap of faith. Still moving. Because I don't even know, man. I guess it doesn't matter, really. Because that's real. that stator is moving on its own power, which has come from the rotor, of course, but it's still, all the power in the rotor is being generated from the stator. And the lens has properly been dealt with. I believe it's from the size of the coil. Teeny coil, teeny lens. Hold on, let me read up on this real quick. I'm taking it off. We're gonna get a closer look. All right, sorry. Let me read this. What is white power, dude? That's an undead? Really? Or did you just spell it wrong? Yeah, we don't do racism here. You're all welcome. But if you're going to do reverse racism on my show, you're gone. Mm. What a bum, Dr. Rothschild. Now you can see the wobble more distinctly when I spin it fast. But because it's sitting lower, it's way lower. It's sitting about a whole centimeter lower. That's going to be enough power to make it run at that speed for a while. You can hear the reed switch clicking. So neat. Now, granted, it's not counter rotating, but it is running on its own power. So neat. And what's really funny is that she's all like, and then she spells white wrong. She spelled it like, you know, like the barrel down's white. Not cool, man. It's not cool at all. I'm just looking for something to weigh that down with. That won't work. I don't think I have anything in the immediate vicinity. That'll weigh it down enough. And make it so it's able to spin. So I think I might end up stuffing maybe a bag of iron powder in here. That's what, like 2 pounds, 2.5 pounds, maybe more. Let's see about under here. Nope. Well, something like this. Like that. I think these weigh quite a bit. All right, let me put the, look at it still going, man. That's pretty cool. Might not be enough. That went down a little bit. We'll see if it's low enough. It should go faster if it's low enough than it did before. Looks like it's working. Wow. See, when I push them down like 2, yeah, both reed switches hit. Man, this is the part where it's like, how do I get it to squish down without leaving leaving the maglev in there? So it has to be a weight thing. These batteries aren't going to cut it. It needs to go down a little bit farther. I'll figure it out. I'll definitely figure that out. I might have to use, I'm definitely going to have to use a different mechanism to maglev or get the weight right. Either one. But I think right about there would be good. I'm going to definitely reprint this, make it, straight. I was thinking maybe I load up the inside here with like penny rolls. Just something with weight that if you stack it full, it won't move around a lot. I got a 10-pounder. That's way too much though. And then I got dumbbells, and that's it. I don't have a bench. But that's a great idea. Large chunk of either metal or like brick, even like a paver or something like that. Part of a paver. But it's not a lot of weight that you need on this. That magnet under there is like not. Thinking maybe 5 pounds would be enough. Let me see what I got real quick. I'll be right back. that's not enough. All right, let's check one more spot. So I'm gonna have to stuff my extra batteries in the box. That's what's gonna have to happen. And glue them in there so they don't move around. Equal amount. Well, I don't know. Maybe penny rolls. We'll figure it out. I know I got some stuff, but it's nothing I can immediately do. See, that's still spinning, man. That's amazing. That's proof. Okay, this is what proof looks like. This is proof of self-running capability right here. You're looking at it. No watts, no amps. This is running on its own power and there's no amps needed. If you want amps, I got a battery for you right here. Let me turn it on. This is what amps does to the whole thing. It'll make it counter rotate. Let's see what happens if I spin it the other way. I'm using a reed switch, so I do believe there's a specific direction now that it wants me to spin it in. So now there are amps going through it. It's a 9-volt battery, by the way. So whatever amps come out of a 9-volt battery. Thank you, sir. Thank you, thank you. Really appreciate that. I believe Make is his name. And he told me that, wow, dude, it looks like your thing can run itself. And I'm like, really? And he's like, yeah. And so I put this together today, and it does. It totally does. Turn the power off. Well, it's a reed switch. It's not any of that stuff. No, no, this is mine, dude. I wish I had a website. See now, without amps, it won't counter rotate because there's no push. There's no oomph. Okay, this is all it does without amps. but that is not going to stop for a while. But with amps, it'll counter rotate. It'll push off each magnet with an equal and opposite force, and it'll counter rotate every time. You got to have your battery like fully charged though. You know, you can't just walk in there with 11 volts and think you're going to get 12.5 volt performance. You're not. Now, for those of you coming in now, how long has it been since I started this up? Maybe 5 minutes. See, but it'll get into this range, like right where it is right now. It'll stay there for a long time. Now, granted, you're not going to run an automobile. You're not going to, you know, travel through time with something going this slow. So don't even mention it. It's like, yeah, but that's what it's supposed to do. But this one isn't going to do that. Oh, yeah, no, I wish I had a website. Cool, Joseph. I think I remember seeing you on the community page several times. What are you talking about? Friction is a bummer. KB. I know it's a bummer, but what are you talking about? Okay. Yeah, without amps, that middle part's not going to spin. Doesn't matter how much friction is there or not there. But there's definitely a lot of friction here. Listen. And it's that top bearing. It's this white ceramic bearing in the top here. It's hugging the pole. And I'm going to try and straighten it up, but you're absolutely right, man. Friction. I just wanted to know like which part of it you were referring to. Because I've done the math on how much energy gets generated from the four coils together. I've had them hooked up to a different motor so I could get readings off of them. Okay? So this is enough right here for it to go for 20, 30 minutes. And there is no power going through this thing right now except for what's it's generating itself. I mean, like when you hear the read switch click, you can see it jolt. So you know volts are doing something. Haha. See, I'll show you how little friction there actually is. Watch. I'll just nudge it. And I didn't even touch it, man. But like I said, that top bearing is really hugging it tight. So here, try this. That's a forceful spin though. All right, let me turn the power on. It must be the 9-volt battery is just not enough. Maybe it's dead. I knew it was half empty when I put it in there. I might have to change up the 9-volt battery for a 12-volt battery. Just because you can charge the 12-volt batteries and you get a lot more longevity and use from them. So, I mean, it's a win-win, except it's a lot less controllable. But you can see those lights aren't lighting up very much anymore. Oh, there's no getting the... Well, let me show you. You're right, and I had the same thought. Okay, right there is about 5 millimeters. And then, so it's about 10 millimeters. Well, 15 millimeters between the magnets and the coils. And then I'm down here. You see how that gap is a lot less down here? So yeah, I had the same thought, man. I'm like, they're not close enough. They're not close enough. And but yeah, this one was supposed to counter rotate, but it was way too heavy. And as you can see, the bearing hole, like the whole piece of plastic broke off and it wouldn't hold a bearing. So that's a solid one now. And this thing hits 88 miles per hour, you're going to see some serious shit. Yeah, 88 miles. I'd love to see this thing go 88 miles per hour. Man, it wouldn't hold together past, 2 or 3, maybe 4. I don't know. I think it goes around 650 RPMs before I stop it with my finger. I know it can go a lot faster, but I don't, because when I put my finger on it sometimes, it doesn't slow down. Hell yeah. Now that's a 9-volt battery. Let me stop the rotor. Turn off the power. And you'll see either the stator either pick up speed right now or definitely maintain. And you know why that works? When the rotor is still, like not moving? It's because all the power and all the hookup is connected the same way that it would be if it was on the outside. So every time a magnet passes one of the pickup coils, it goes to the cap bank, and it just works like a regular motor, just in reverse. So you got to put your power source, you got to put your coil, and you got to put your switching mechanism all on the rotor. So that's power. That's awesome, man. That is so cool. I never actually got. It all lensed itself to death, and then finally I'm like, well, if doing it with the magnets in the middle isn't working, so what am I going to do? So I put the coils in the middle, and guess what? Yeah, lens is gone. It's not even there. What's up, Frank? Let me read this real quick. What about a coil slightly slanted to push the magnets? Yeah, that might be a an engineering problem. See how simple this one is? They're all at 90. It's nice and pretty at 90 degrees. But what I want to do, honestly, in regards to what you said, Frank, uh, is to put coils in between each coils at 45 degrees and have them be pickup coils all the way around at all four corners, and then hook it up to in series with the other four. Um, let me read that one more time. No, the only battery on this is right here. It's alkaline 9-volt battery. And no, it's not an MRI machine. I think that'd be sweet, though. I think an MRI machine's more toroidal, though, because you can put your head in the middle of that. Or wait a minute, that's a CAT scan, right? I'm not sure. All I know is that the one thing you can put your whole body in, and that's toroidal. There's nothing in the middle. It is a similar principle to an alternator, but it is, from what I hear, incomplete to be an alternator. Yeah, toroidal. Donut shape, toroidal. Now, granted, watch this. And this is going to throw everybody. And you'll see why I was doing it slow, just to show you what was really going on. Because when I do it fast, of course you think it's momentum running the whole show. But that's why I did it slow to start, because it's not. Now that's momentum right there. That's what momentum looks like. Right? And this and what you saw earlier are not even close. Now I do want to show you guys again the counter rotating pulse motor, not the self runner, because I believe it's more fun. But yeah, let me put you up here real quick. Swap it out one more time for people that are showing up. See, we got the counter rotator and then we got the solid state down there. And they're both pretty cool. I like the counter rotator personally, but I think the solid state is a lot more sturdy, stable. This isn't stable. This is if I'm not on top of my game, lots of bad things can happen. What I mean is this could go whoosh. Like half of it go that way and the other half go that way. Or this way, which would be even worse. Now see, there's only 2 pickup coils on this one, so the second drive isn't going to get like the boost that the other one gives. There's only 2, and on that one there's 4. But the idea is that the faster that the battery makes it go around, then the pickup coils will generate that much more. But I don't even know if it's anywhere near the amount that the battery's giving it right now. With 2 coils, it's probably less, like a lot less, like 6 volts instead of 12. Because it's 30 gauge. It's 30 gauge. And I usually work with 32 when I'm doing pickups because it's, you know, the difference between a 32 gauge pickup coil and a 30 gauge pickup coil is about 200 volts. I'm talking about a big one, like say this size, but the same amount of copper, same length of copper. You're gonna get way more voltage off the 32 than you are the 30, way more. Yeah, the output gets rectified. Both of these have rectification cap banks on them. Yeah, the output's definitely rectified and then just reused immediately. Because I'm not trying to run an automobile, this is the automobile. Well, this will spin until I turn it off because it's got a battery hooked to it. But this one right here is different. I have no idea how long that the stator will spin for that. It was going for 20 minutes. My sister looked at my sister and she said, "Bro." I don't know, man. It's all the girls at my old job would be like, "Hey, bro," to their sister. It's like, wow, it's awesome. It's awesome. No, just a memory. Depends on how many batteries are in there. I know this is gonna sound like really weird, but the last iteration that I built this, I had 2 batteries in there, 2 drives, parallel drives with their own batteries. They went in at 12.5. Okay, fully loaded. When I checked them, when I took it apart, 13.5 on one and 13 on the other. Without it being hooked up to anything to charge it with. It just happened. Oh man, that's one of my favorite places, bro. Coral Castle, man. Sweet 16. That's what. Yeah, that's. I didn't even read what you wrote, man, and I already know what you're talking about. I read it now, man. Yeah, it's exactly right. Yeah. There can be another whole like set of pickup that you can run in series with the current pickup, just on my model of this. But of course, I would have to find a way to fix them to the rotor. But that's like the only place they can go is at 45 degrees on the rotor. Um, there's really no other place to put them. So 90 degrees and 45 degrees, or 45 degrees all the way around. And yeah, man, and you only need one coil, one drive coil. That's it. One 200 turn drive coil. Maybe 2. You can do a 180 circuit with this build. Um, but it's powerful, man, and you want your infrared toggle switch on there before you run with 2. And believe me, man, you're gonna need a wireless toggle. Oh, I haven't. No, I haven't tried a linear motor. You know, till this, it was all pretty much like Bedini style motor. Like I wouldn't call it Bedini because my version of the circuit doesn't have a resistor. It doesn't have a diode. That's pretty much it right there. You got 1, 2, 3 connections for the emitter, 2 connections for the collector, and that one for the base, and that's it. Nothing else. It's moving. And that chirp, I believe that's the disruption of atoms around the coil. But you know what else disrupts atoms? You can break wind and that'll disrupt some atoms. Yeah, it generates its own energy, bruh. Absolutely. No. That's a great idea, but no, I'm never going to do that. You can definitely try that. There's no patent here. You know, if you want to build one, you are more than welcome to build one. So you're telling me that this would be an alternator if I hooked it up to the engine? No, Gregory, that's boring. It's fucking boring, dude. That's what everybody tries to get me to do, to just stop it. No. So I just proved that that's bullshit. No, man, no. See, that's the thing, man. You want to get measurements? Then you don't build a counter-rotating electromagnetic rotor. You don't do that. You want to get measurements, you build a coil on the outside, and you got your neo spinning in the middle. Or you could put it on here, or in here somewhere, right? But it isn't going to be connected to anything out here. Believe me, man, I've been down that rabbit hole already. My mind is very open. I've done 1,000 motors like that. I'm choosing to relinquish control. That's my choice. And see, I don't need to control it. There's no need for any control at all. Look at it. It's perfectly safe. It's perfectly controlled. I totally and I said to myself, the third time I stopped it with my finger without infrared toggle switching. There is no control. You have none. I'm not giving up. I'm definitely not giving up. Thanks, Gregory. No, I'm not saying I don't appreciate your input, but I mean, like, you just told me that you need to solidify stuff and make it so you can get readings and stuff, and look, it just stopped. So no, that isn't it. That is not where the money is. But I am like 100% encouraging people to go out and try it. Instead of giving me a million suggestions on what I need to do, I'm taking into consideration all of your suggestions. Don't get me wrong. But build your own. Thanks, Gregory. Yeah, you go ahead and you add mercury to yours, bro. And where the hell would I put the mercury anyway? Wow. I mean, yeah, the mercury will facilitate momentum when spun. That much is clear. And it's, I believe, conductive. Yeah, I hope I don't, well, blow this up anyway. You know, the last one, I was, it was going really, really fast. It was really, really balanced, and I just let it rip, and like half of it just went flying across the room. So yeah, I'll watch myself. Thank you, Gregory. Um, it's a counter-rotating DC pulse motor. I know that's boring, but shit, that's what it is. Yes, read switches, definitely. Good night, Gregory. Thank you, sir. Appreciate you. I do. All ideas are welcome here. Mercury, probably not going to happen. Very deadly. It's poisonous. That's why I encourage, mercury. You can do that one on your own. You could just put an O and a K. That would do just fine. Oh, society, man. What's up? Maybe. I've never busted open an air conditioner to find out. This is a counter-rotating DC pulse motor, society. And the only reason it's manageable right now is because I got 3 magnets on the outside. That's the only reason. You can imagine how much more torque and speed there would be with 6 magnets in there instead of 3. But it's stopping. I think the battery's dying. Sounds like it's dying, doesn't it? I'm going to let them juice up a little bit. I'm going to put the other 6 magnets in here too. Yeah, no, I don't doubt it, but I never got the chance to mess around like that. Now what we could also do is go north-south, north-south with the 6 magnet spread. Because I heard north-south, north-south was better for generation purposes. Yes, sir. Yeah, that battery's dying. That's awesome. Thank you, society. Thank you. And fuck farming, man. That's all going to the robots, dude. Don't even worry about it. Don't even worry about it. It's true, man. The world's about to change in an extreme fashion. I'm sorry, man. That's real. Even humanity itself is going to change. It's going to branch off in 3 directions. Okay, and then they're going to join back up in the future. Humanity isn't going anywhere. All right. So we got humans, 100% homegrown humans. We got cyborgs, cybernetics, implants. We already got implants going, so don't tell me it ain't real. And then we got 100% robot. And all these things can house a soul, will be manufactured to be a person. And that's it. That's real. We've already established all 3 of these branches. All we have to do now is establish the consciousness. In the robotics, you implant the consciousness, same deal. Consciousness, especially how they feel about religion and things like that. So yeah, the consciousness. There's what? Sounds like a 15-year-old simplification. I'm getting tired, so I can't read all this stuff. I'm trying to. But yeah, essentially, you've got your battery, you got your coil, and you got your switch. Bingo. And I don't know, man. I think I just ruined somebody's night, but I'm sorry. I don't think it's funny. I'm just trying not to, you know. So I'm going to be wrapping it up here in a few minutes. It's been 3 hours. I think, I hope people enjoyed this. And I enjoy it. I'm just trying to think beyond this now. And see, there's still so much I got to do with just this before I can move on to all of that. So it's like I got to get this unwobbled. It's got to be a straight print. You can see how like messed up that stator is, shaking the whole table. So like, yeah, all, but yes, I don't know exactly. I need a partner. That's what I need. Somebody who's willing to let it all go. Everything they know or think they know. Somebody who's just willing to flush it all down the fucking toilet. And say, oops, I got it wrong. You know, oh my God, man, maybe there's more to it than what I thought. That's what I'm doing right now. And yes, this, I don't know if there's enough torque with this one, this rotor to run a belt, but yeah, you could hook a belt to the outside of this, run the rotor, and it will pulley the belt with the proper amount of torque. And that's not it. That is so not it. This is amazing. I think it's because the battery's dying, honestly. But I can charge it, so I'm not worried about it. So like if you're telling me that, because my buddy, and he's really good at making these things, man. He does Arduino and all this stuff, and it's all controlled and everything like that. He's like, you got to get your stator to stand still or it's useless. I told him to fuck off. And I've known him for, 10 years. I just said, screw you. We haven't talked since. But I'm gonna try and get a hold of him again. Man. Just because I like him, man. He's my friend. But I mean, yeah, no. I've done 3,000 motors like that and I'm done. It's boring. And then the electromagnetic rotor, the only way you're getting readings off of that is wirelessly. Like legit readings off the coils, you need to get all that done through a wireless reader. Because if you hook anything to that, it's going to stop. Except for a transmitter. Transmit the data wirelessly. That's what I say. Yeah, that's wobbly, man. Wow. Yeah, no, printer, maybe printer something. 3D printer something. And you know what I would do, honestly? I would have PCB way, and I'm guaranteeing myself this would cost me like probably like $3 grand. But make this aluminum and a cap that's exactly the same as the bottom in aluminum. Now, granted, the magnets will be slightly yoked, but that's okay because you can't really tell from this one the way it's going. But that yoking is probably going to be a good thing. Whoever's been watching, my previous iterations videos on this thing, when I stop it with my finger, you know that this is not what was what's going on here. This will stop with me touching it, basically. I don't know what the hell the problem is. I know, no, never mind. I know what the problem is. See if we can get some speed. It's a counter-rotating DC brushless motor. Yeah, I'm reinvesting it. One circuit creates the DC power by spinning it, and the other circuit eats the DC power to spin it faster. Oh, let me put my other rotor on, jackass. My other rotor. I'm gonna, dude, you said that to the wrong gentleman. Now there's no power on this one. Yeah, but the battery that I was holding up does power the other one. This one has no power. Yeah, that is something that I might look into, is to wire up the back EMF. I could do that. But you got to understand, every single thing that I add to this is going to make it that much more unclean. See, right now it's like so simple. It's like, yeah, I'm getting so tired right now. It's not even funny, man. I'm misreading stuff. It is not good for people out right now. Um, with this one, I I believe it's probably right around 4 consistent DC volts, maybe less, maybe like 3 or 4, depending on how fast it goes. And then when it stops, like if the rotor stops, um, maybe 1.5 volts. Anyway, it's running on a reed switch, so it doesn't really matter. Any voltage will make a reed switch pop. Any magnet will make a reed switch pop. Thank you, Yoda. Yoden, what's up? See, now this is where it falls into the zone. See, by itself, without power, you don't get amp oomph. You don't get it. It's not going to happen. So what you have is voltage that comes off the pickup coils. And as you can see right now, it's fallen into the zone, is what I like to call it. It's not slowing down. It's not speeding up. So the amount of energy that's generated from the 4 pickup coils as this thing rotates is enough to keep it rotating at this speed. This is equilibrium for the power. That is, I don't even know what I'm trying to say right now, but it's running itself well at this speed. And when I get down in here, you can hear that reed switch clicking, right? You can see it work. You can see it move when the reed switch goes boop right around here. And I don't care how long you've been doing this, really. It doesn't matter how much you know. You are not going to tell me that I'm not seeing in front of me what I'm seeing in front of me. It just isn't going to work. Yes, it is. Yeah, I call it the range. The range. I don't know. Yeah, the most efficient time of its running, and then it'll slowly dissipate, slow down, stop. I'm gonna give it a whirl because I don't. My idea is to get this thing going like at least 2,000 RPMs, right? And then hit the infrared toggle switch, which will cut the power, because you're not getting it, 200 by spinning it. You're just not. It's not going to happen. 2,000, I mean. So, you know, you get the rotor going 2,000 RPMs, and pop, cut the power. See how long that'll run for. Now, see, there's supposed to be some sort of lens happening, correct? Maybe. I got another rotor that's designed for compressed air. It's like a little, it's like a 12-finger whirlwind of spinnakers, man. It's awesome. And then it'll take water or air. Take both. I don't even know what that is, though, KB. I'm really, man. I mean, it may seem like another level. I don't know anything really about this stuff. I know what this does, and I know it very well. I don't know all what other people think about it, but you know, and I don't know like pretty much all the components. I don't know offhand. Like everything that I could use or might need, I don't know any of that stuff. So, what is a counterfrugal switch? Centrifugal, my bad. I'm just, you know, putting forth my shortcomings. I'm not an electrician. Okay, I paint. I'm an artist. Oh, so like the inertia of the spin will force it to close. That's awesome, man. Really? Yes, that's exactly, that would be awesome. F yes, dude. All right, I'm gonna stop it. Not being wobbly, it might not take hold because you know it dips and then it's got to climb a mountain and then it goes down the other side. But if it can make it over that hump, man, this just right here will go and it'll continue to move for until I stop it. So tomorrow I'm gonna open this up and I'm gonna fill up that box with some weight so that the coils will sit a little lower. And we'll get more magnetism on the coils, which is gonna make everything run better. I can tell you right now, there is no way that that little nudge that I gave it has got this momentum. There's no way. And I know it's slow, it's boring, but it is running its freaking self, dude. 100%. Yeah. All right. I do want to show you guys something. The latest group of people to come in. I'm going to unhook the reed switches now. Now this isn't for motion. This is for the cap banks. Watch those lights. Now it's not being spent now. The energy is being collected now and not being spent. See the red lights? Kinda. Right there. That's all energy that's being collected from the pickup coils. Counter rotation does help that collection. Okay? It makes it better. Yep, counter DC, brushless, counter rotating pulse motor. Yeah, I'm hoping to make it run like a lot smoother because I have an image in my head and this is not it. See, in my image, it's like really smooth. So, I mean, like it's as smooth as it can be. It's got the right bearings, it's got the maglevs, so it'll move. But I mean, look at the wobble on that thing. It's like an orbit. You know what I mean? It's like the orbit of Pluto. Yeah, I know the Pluto's got more than one orbit, so I know what I'm talking about. Yeah. So I need to print a new one of these. I don't know why it came out so crooked. But yeah, once I do that and I fill in the box and get it a little weighted down, it should be awesome. Like, from the top it looks good. Yeah, I use ceramic 4-inch ceramic toroidal magnets. Yep, 3D printed. All this is 3D printed. I mean, my rotors turn out really good because I get to use my K1C, but I got to use an older printer that has the bigger bed to make the Utron here. And it doesn't work very well. So I'm hoping that the next one that I try when I buy more filament is going to turn out better. Because it really sucks when you spend all that money on the filament and then it turns out like this. You're like, wow, man, that sucks. I mean, and it works though. It works. I'm not saying it doesn't work. I'm just look at the magnet on the bottom there. I mean, that magnet will start grinding on the other magnet if you put weight in here. But just that one part that dips down. It's like whoosh, whoosh, whoosh. Now see, the rotor always stops. And I believe it's because of the third bearing that I have in the top to center the plate that everything's resting on. See, but no amps, you don't get any force. All right. So you guys saw that the energy come up in the cap bank, right? You guys all saw that? The red lights. They're dim right now, but like if this thing ever gets going fast, those will light up. Well, they won't light up. That's what I'm getting at. Once you plug it in, once you plug the DC side in, they don't light up anymore because the energy goes straight through the cap bank and into whatever the DC side is as DC electricity. So once you do this, on run yourself, because I've with the motor over here, I can run 3 motors and have reserves in the cap bank. But for some reason, and I think it's because the coils are so much bigger. It's like that's the reason why. And I was also wondering if see right now I have 2 drives. I have 1 drive connected to each cap bank. And I was thinking, well, what if we just unhook one of them? And we only have 1 drive, like the front of the box would say. um, let's look. There you witness the hump right there, the wobble, and what damage it causes and all the rotation and whatnot. And this is the bonus. When the reed switch pops and the drive, opens or closes, when the drive closes and is, what's it called? Grounded. You get a burst of energy to the pickup system. So every time that thing pops, the energy that is in that coil right there is also in proximity to a pickup coil. Boom. It's a perfect system. Just have to know where to go with it from here. I think it's push, not pull. So all the magnets are north out. And I do believe that all the coils are south wound. So they're all wound clockwise rotation. So I believe it's south on south, not reverse polarity. I think that's awesome. What's going on right now? Because you see how slow it's going, right? But it's going fast enough to generate enough voltage so that when the reed switch pops, you get a forward momentum, like push. You get a push, but it's a voltage push, not a wattage push. How much wattage or how much amperage is this thing generating? I'd say at max 150 milliamps. There it goes. Oh, is it going to stop? It's going to stop. Or is it going to fall? It's going to fall down the hill. It's falling. I don't know. I know that in order to get up that hill, you need some kind of force to do that. Yep, there it goes. So when I get a new one of these that is hopefully flat as a pancake on the top here and flat down here on the maglev, and then put some weight in it so it's down a little bit like that. And then I think one of the reed switches, when the wobble is tilted low, it doesn't trigger the reed switch. It's too low. So there's fix these little problems, man, and this thing will be way cooler than it is now. Thank you, Yoda the man. Yoden the man. Very cool. Yeah, man, it's literally running on its own juice. So this ratio is 4-to-1. 4 30 gauge pickup coils that weigh 5 ounces, and then two drive coils that weigh 5 ounces. Okay. Dan the man. All right. All right. I like that. I mean, you can argue with me that this is from when I spun it, but I think we started it from a dead stop. So cool, man. I had to share it because I didn't think it was possible due to lens. Due to the lens, I did not think it was possible. But with the electromagnetic rotor, there's a difference. Lens isn't such a big deal. Yes, 10 people didn't like that. What? No, I've done all the tests on another motor with the coils though. I know what's going on in here. Okay, I don't need to test this. I've done all my testing already. But I can tell you right now, we're generating about 1.5 volts at this speed, and that's enough to make it continue to rotate. And if that's not good enough for you, man, you know what to do. I think this might be it. We'll see. Yep. All right. So, will it run forever? No. Did I ever say that? No. Do I believe in that shit? Fuck no. But you know what? I don't have to believe in it for it to be real. And that's a fact. Let me put some power in this real quick. See how much power is going to the cap bank now. All right. So let me turn this off one more time. Let me plug back in the other. That sucked. Dang. Am I going to be able to do this with one hand? I don't know. All right. I'm going to do this real quick. I'll be right back. Nah, man. 32 is hard enough to work with. And I believe we're gonna, if we need any amps, we're gonna get way more amps out of 30 gauge than we are 45. But I didn't read the message. All right. Apologies. Well, I don't know if this is a free energy device. I don't know if I believe in that. But, you know, somebody described free energy to me a different way. So now both reed switches are hooked up, and that is definitely gonna work. All right, let me turn the battery on. You know why I think this one isn't never will counter rotate is because all the drive coils are the second ones. All the pickup coils are on the outside. So this one isn't really designed to do that. I was wondering what would happen when I built it this way. But we will see what happens tomorrow. See, but I think you're really just fucking wrong about what I'm doing here. You think I'm trying to make this thing spin forever, and therefore friction becomes the enemy. I'm not. Dude, I'm so not trying to make this spin forever. I said it can spin on its own. I just want people to frickin' remain clear that that is what I've said, and that's exactly what I fucking mean. I don't believe in all that crap. I don't believe in it. It just doesn't float my boat. This is real. You know? All that crap that's going on in your head is not real. Because friction is the enemy. And yeah, we'd have to build it in space. And yeah, all this other crap in a vacuum chamber and all this shit. I'm not doing that. Just to make it spin for, 4 years? Who cares, man? I'm going to die soon. Not like really soon, but 50 years is soon to me. Oh, man. Yeah, maybe it's time to call it. Man, I apologize, KP. I read too much into what your first message said. So that's totally my fault. Honestly, I believe that if you have more than this isn't enough, but if you have a third layer and maybe a magnet in the center, you could travel dimensionally. I don't know, man. I don't know. Wow, it's been 4 hours now. Holy cow. Man, and I don't know, I felt comfortable letting loose tonight. I don't normally do that. Whenever I do that, I usually get oh yeah, man, forgive me. Forgive me if I jumped down anybody's throat. Forgive me if I sounded dickish. Oh man, you want to see anti-gravity flyer? Old man builds, man. He's got one that is pretty freaking awesome. It's not, yeah, you're right, absolutely right. What happens here is that the magnet releases the energy from the pickup coils, and then it's not free; it's generated. That's totally different. Yeah, you know it. You know it. I'm like thrilled, man. I've made now like 9 of these things, and some of them have run on commutator plates, some of them are run on reed switches, some of them have run on transistors, um, some of them have run on a homemade switch, like just 2 paper clips. But my first one, man, I'm gonna zoom over here real quick. That's my first one. And that one runs on a reed switch, but it's missing some pieces. So I gotta print them off again. But see, now the power is on right now. Okay, so don't be fooled. This is not um so I turn the power off. So right now I think it's about 3.5 volts is being generated. But is 3.5 through the reed switch enough to rotate it at the same speed? I don't know. I don't think so. Nothing is going to slow down. That's why I want to speed it up like 2,000 RPMs and then cut the power like right then and see what happens. Because you can't turn the power off on this without stopping it. But with that being said, I think I'm gonna rest up. I'll get a hold of you guys. Yeah. Yeah, that it will remove the friction that you were referring to, and maybe you're right. The only friction that will be occurring there is the gravity, um, but it's a lot less than what's going on down here. What about those rays that are supposed to be hitting us in the next, 36 hours to 48 hours, like the central hole in the sun rays? Well, the winds, not the rays. It's the solar winds that's coming out of the center of the sun right now. That's headed directly because it's at the equator of the sun. It's going to hit us directly on our equator. Yeah, they said that the solar winds would, mess with stuff, change frequency, do all this kind of weird stuff that, it's really hard to monitor, and you can't really prevent any of it from happening. You can just kind of look at it when it happens. Yes, that's it. Yes, sir. I think we're going to live through this. But who knows, man? Who knows? What if it hits a frequency and all the water just goes like in Batman? Because, I mean, if water boils and evaporates at a certain temperature, that would mean that there's also a frequency that it would happen at as well. This is a counter-rotating DC pulse motor. This is currently running without power. But yeah, man, if there's a sign up sheet for going to Mars, I'll put my name number one. That's M.P.H. JR. Let's go. Ah, I see gigahertz. Well, the sun, I mean, is going to be able to hit gigahertz no problem. Hell yeah. And that's pretty much all they do is agitate water. Because you can put virtually anything in there that has any kind of water in it, and it'll cook it. Thank you. Thank you. Thank you. Oh, I just have to ask, what's a ham? I have no idea. Well, it's the ass end of a pig. I know that. But what is it in this context? Mm. Hello, hello. 6G, 7G, run gigahertz. Oh man, I can't wait. I'm excited. Oh, I see what you're saying. Yeah, I've been seeing these new, guns on the warships and stuff, man. No kidding. 100 gigahertz, no problem. Okay. Yeah, that's true. That's true. It's as true as saturation. This is a counter-rotating DC pulse motor that can run itself for a little bit, and not anything spectacular. It runs pretty slow, but it'll go without stopping pretty much. I have to stop it so far every time. Terahertz? Is that what that is? It's a counter-rotating DC pulse motor without a battery. And the cap banks are empty until I start spinning it. No, sir. There is a battery on here. I do keep a battery on it with an on-off toggle switch. It's currently off. I'll like stop it, slow it down. No. And I'll move like that until I stop it. So it's powered by the pickup coils and the magnets. Thank you, thank you. And right now the magnets are generating enough electricity for it to continue to spin the magnets. But just enough for it to keep moving, really. All right, I don't want to go, but I'm going to wrap it up in like a minute. I really appreciate everybody for coming through and expressing themselves. Um, I like what's going on here. I just hope that I can make the necessary adjustments because this is supposed to have a lid. It goes on it and connects with these mags and just sits on it like this, kind of exactly like this one. And then you just spin the outer shell. And with the proper rotor, and it'll continue to spin until the battery runs out. And that's pretty much what it is. And you know, I want to kind of do like a magic show with little kids and like spin this thing, and then they're gonna be like, "Wow, it didn't stop! Oh my God!" And you know, that'd be great. No, sir. I got an education as an accountant, and I'm an artist. I like to paint. I do this. I hooked up with a friend on YouTube. Well, hook up is wrong word. Uh, Collaborated. I just use hooked up because that's what I do. I hook up a bunch of stuff. But we collaborated, and you know, he shared a bunch of his knowledge with me. Um, and you know, all this stuff is what it was derived from what he told me, word of mouth. Um, I learned this from, you know, talking to the wisdom people. uh, Thank you, sir. I appreciate that. And it's not, yeah, I can't take credit. The Crow on TikTok, and there's two people that I'd like to thank. One is Kale. That's his name. His name is Kale. And the other is Mike B, Kale's sponsor. They both, Mike B indirectly helped me out, and uh, Kale helped me out a lot. Yeah, man, he sat me. He said it was awesome, man. And you should, if you want to check out any of my previous videos, um, like way back, like if you hit reverse on the time on the time tab, you know, go into my channel and go reverse on the time tab, and start looking from there, man. You'll see the progression, and it got messy over, you know, and it started real clean because I didn't have anything, and then it got messy because I had too much stuff, and then and now it's like now I'm in a little corner in my room because you know I'm trying to narrow it down as to what I'm going to be working on. But thank you all very much. Peace out. Have a wonderful night. Please be cool. Thank you. Oh yeah, KB. I think I remember, like, you've been around all the different places that I've been, yeah? Like in my living room, the other part of my bedroom. Yeah, dude. So, I mean, it all basically came from Kale and Mike B. And then Mike does. And old man, he helped me out a lot. It is a self-running DC pulse motor, counter rotator. There's no power in that right now. It's running on its own power. But good night. Thank you so much. And that's so true. Nice name. Peace out.